Okay, we are on page 52. And this is where the questions get a little bit harder. I'll do my best to explain it to the best of my ability, but if you need extra instructions, please ask me. Financial literacy. For numbers 14 through 16, use the table. The table shows Jason's utility bills for 1 month. Write a fraction to represent the division in each situation. So the first thing we're going to do is we're going to figure out the division problem, but we're going to represent it as you're going to use a fraction to represent it. And then the next thing we're going to do, then classify each result by indicating the set or set to which it belongs. And what we can do here is we can just ask ourselves, is it one of these three things right here? Okay, let's kind of put this in the corner. Alright, question 14. Jason and his 3 roommates share the cost of electric bill evenly. That means Jason plus his 3 roommates, that's a total of 4 people. 4 people are going to share the cost of the electric bill. So the electric bill is $108. So we're going to do $108. And that's going to be divided by how many people? 4. 108 divided by 4. Now some kids would want to solve this, but the first thing it actually asks you to do is not to do 108 divided by 4. It actually asks you to represent it as a fraction. So instead of doing 108 divided by 4, I'm simply going to do 108 over 4. $108 divided by the 4 kids. Now some kids wouldn't be okay with leaving it there, even though we really have answered the first part of the question. The question read, write a fraction to represent the division. This is a fraction that represents the division. It's $108 divided by 4 people because they're sharing the bill. Some kids would want to solve it, and you'd be allowed to. 4 goes into 108 27 times. So you could solve that and write $27 each. But the other thing you're supposed to do, so this part of your answer is optional. The other thing you're supposed to do is identify what kind of number that is. Well, what kind of number is it? If it's written as a fraction, it's a rational number. So that's one answer. And is it an integer? Well, integers are positive or negative whole numbers, and that's a positive number, so I could write it as an integer. Let me go back to this, rational number, comma. It's an integer. Now, is this a whole number? Well, it doesn't look like it, but it simplifies or divides out to be 27, which is a whole number. So it is actually a whole number too. So believe it or not, that number belongs to all 3 sets. All right, and if you're wondering, well, how did you get these last 3 word answers? I just asked myself, where would 108 over 4 go? Well, it'd go in the rational numbers. It would go as an integer as long as we wrote it as 27, and it'd go as a whole number as long as we wrote it as 27. All right, next. Question 15. Jason plans to pay the water bill with 2 equal payments. The water bill is $35, and he's going to divide that into 2 payments, so that's going to be 35 divided by 2. And the first thing we're going to do is write that as a fraction, so that'd be 35 over 2. And we could solve that, that's an option. And what we're going to get here this time is not a whole number, because 2 doesn't go into 35 evenly. It goes in 17 times, because 17 times 2 is 34, so there's 1 left over. It's 17.5. Or if you wanted to, you could make it into money. $17.50 would be $17.50. Now, many of these answers are optional. I didn't have to do 17.5, and I didn't have to do 17.50. The answer is 35 halves. What kind of number is 35 halves? Is it an integer? No, integers have to be whole numbers. They can be positive or negative. Is it a whole number? No, 17.5 is a whole number. There's only one kind of number that it is. It's a rational number. So we need to include that off to the side, rational number. All right, there's one more question in this set. Third question is, Jason owes $15 for last month's gas bill also. So the gas bill is $14, but he also owes $15, so we're going to have to add those up. Because if you don't pay your whole bill, they tack it on next month. So Jason owes $15 for last month's gas bill also. The total amount of the 2 gas bills is split evenly among the 4 friends. Well, the total is going to be 14 plus 15, that's 29. And that total, 29, is going to get split by the 4 roommates. It's not 5 roommates. Sometimes we add those up. Let's go back up to number 14. It says Jason and his 3 roommates. That means add them up and get 4. This one we don't add anything up because it doesn't say Jason and his 4 roommates. It says among the 4 roommates. There's 4 roommates. It's not Jason and 4 more people. It's Jason and 3 people. It's a total of 4. So it's 29 divided by 4. That can be written as 29 over 4. $29 divided by 4 roommates. And is that going to be a whole number? We don't have to finish solving this. We can. But we have enough information now to answer. Is this a whole number? No, 4 does not go into 29 evenly. It's not a whole number. If it's not a whole number, it's not an integer, because it's not an integer is a positive or a negative whole number. And a rational number, yes, it's a rational number. Rational number is anything that can be written as a fraction. That's a fraction, so it's a rational number. All right, let's check out number 17. Number 17 says, Lynn has a watering can that holds 16 cups of water and she fills it half full. Then she waters her 15 plants so that each plant gets the same amount of water. How many cups of water will each plant get? Here's the problem. There's a bunch of numbers here, but you don't need them all. I could draw a picture. I could do a watering can. I'm not the best artist here, but I'm going to draw a watering can. And that, of course, is the spout. And the whole thing is 16 cups. That's how full it could be, but she doesn't fill it up. It says she fills it half full. So how much water does she have? Well, half of 16 is 8 cups. So she has 8 cups of water, and we don't need this number right here, 16. We used it to figure out how much water she has. She has 8 cups of water. So she has 8 cups of water, and she's going to divide that among her 15 plants. 8 divided by 15 is not a normal type of division problem. You can't really solve it. So this is one of those problems where we're going to want to turn it into a fraction, where the first number becomes the numerator, and the second number becomes the denominator. And 8 divided by 15 is 8/15. How many cups of water will each plant get? 8/15 of a cup. That is confusing. I'm not saying it's not. It is confusing. But as long as you are identifying the numbers, and as long as you memorize this skill right here, which is the dividend becomes the numerator, and the divisor becomes the denominator, then you're just basically following steps. You're taking the first term, and it's the numerator, the second term, and it's the denominator. Okay, we're going to go through these hot questions really quickly. They're not too bad for hot questions. Often the hot questions are the hardest ones. I'll do my best on these to explain them. You can watch the video a couple times if you need to. Question number 18 reads, DeMarcus says that the number 24/6 belongs only to the set of rational numbers. Explain his error. I'm going to bring this up here. And it makes a little bit of sense what he's thinking here, because 24/6 looks like a rational number. It looks like it should go right there, doesn't it? So should we say that he's correct, 24/6? The problem is he's not thinking 24/6 all the way through. 24/6 is a rational number, but is it more than that? Well, what is 24 divided by 6? It's 4, and it's just 4. 6 goes into 24 4 whole times. What kind of number is this? That's an integer and a whole number. So he is wrong. 24/6 is not just a rational number. It is a whole number. It doesn't look like it, but it simplifies to a whole number. 4 is clearly a whole number. So I'm going to help you write a good answer here. Since 24/6 means 24 divided by 6, I'm not going to write that. So 24/6 simplifies to 4 whole. It is both a whole number and integer, as well as a rational number. The tricky part about this one was that it looked like a rational number because it's written as a fraction, but if it simplifies to a whole number, then it's actually supposed to be a whole number. Alright, let's check out number 19. And I need to do a little of erasing real quick, just to get some stuff out of my way. Here's a Venn diagram right here. Question 19 reads, explain how the Venn diagram in this lesson shows that all integers and all whole numbers are rational numbers. So, let's say I have an integer in my circle here, and like just -3. I'm going to change it back to black. -3, that's an integer. Or I have a whole number, just like, I don't know, 9. So here's what the question is asking. How do I know that those things are also rational numbers? Well, here's how you need to look at it. If I got rid of this circle, and I might do it, I might try to get some beige and color it out. If I got rid of this middle circle, if I got rid of the integer circle, It almost looks kind of good, actually. I got rid of the integer circle, and I crossed off this word. Where is negative 3 now? Is negative 3 right here, is it inside the rational number circle? It is. And if I got rid of this circle right here, now I just have one oval, and 9 and negative 3 are both inside the rational numbers circle. And so what we can say here, and we could go to the explanation of, well, negative 3 can be written as negative 3 over 1, but that's not really what this is asking. It's saying, explain how the Venn diagram shows this. Well, since the integer and whole number ovals are inside the rational number oval, it means that all integers and whole numbers are also rational numbers. Again, tricky, but just try your best to understand what I'm showing you there. Okay, we've got one more question, and I need to move this up and project that question. And I'm going to use this Venn diagram to help you with my explanation. Question 20, critical thinking. Is it possible for a number to be a rational number that is not an integer, but it is a whole number? Explain. So I want it to be a rational number and a whole number, but it can't be an integer. So let's think about that. How about this? How about an example? A rational number could be oh no, what did I do? There we go. Clear that. Okay. A rational number could be something like 9 over 10. Now, is that a whole number also? No, that doesn't meet the expectation, so that's not going to work. How about a whole number like positive 9? Is positive 9 a whole number? It is. Is it also a rational number? It is, because I could put 9 over 1. Is it also an integer? Well, it actually is, because integers are whole numbers, positive or negative whole numbers. So, here's the question. Can it be a whole number and a rational number, but not an integer? And the answer is no, it can't. The answer is no, and that says explain. Every whole number is an integer. And then we might say because integers are positive and negative whole numbers. That's their definition. That's what an integer is. It's a positive and negative whole number. So, the answer is no. It can't be a whole number and a rational number without being an integer. Alright, well, good job on that. We are now done with page 52.